Hello and welcome. This is going to be Electronics 5. Electronics 5. Okay, so we got up to describing a static electricity. So today what I want to look at is going to do conductors, insulators, and electron flow. Okay, so this is when we're going to move on to this is sort of well, it's still at the chemistry stage, I suppose, but it is going to be moving to be more specifically about electricity. So basically, electrons in different atoms, different types of atoms, rather. This is, have different degrees of freedom. Degrees of freedom. So depending on the type of atom, the electrons are going to be able to be either free or less free. And so let's look at how they're categorized. So let's look in metals. So in metals, so the outermost electrons in these atoms are very loosely bound. So even at room temperature, so it's quite an interesting thing if you just got a, if you just got a piece of iron or something, or just a metal, or something, anything metallic really. So even at room temperature, these electrons are actually moving about. So even at room temperature, these electrons are moving in the space between the atoms. Between the atoms in the material. So they can move, yeah. So they can move in their own atom, also move between the in the space between the atoms. So yeah. So these are these electrons are virtually unbound. So there's no so there's not a huge amount of restrictions for them. So they're called free electrons. And I'll capitalize this because it's an important term. Free electrons. So these are not, there's no restrictions on the electrons in atoms, in metallic atoms. Okay, so they're free. Okay, so now in other materials, obviously I'll define them very soon. So other material, I decided to remove the top bar, the thing at the top, just so there's a bit more screen space. So in a material like glass, let's just take that as an example. In a material like glass, the atom's electrons have much less freedom to move around. Okay. So these are much more restricted. So as was mentioned earlier, in the case of wax and wool and silk and glass, as mentioned earlier, rubbing can transfer atoms to another material, can transfer electrons to another material. However, these electrons tend to remain stationary. Okay, so tend to remain stationary. And as I mentioned, obviously, static electricity. It's stationary static. So there's much less movement than in metals. So yeah. So for instance, as I mentioned before, you got the wool transferred to that in the wax, but they're not going to be, the electrons are not going to be moving all over the wax. It's only going to be in a small place where they transferred. Okay. So, and yeah, obviously they've got the surplus there, but it's not going to be uniformly distributed or anything like that. Okay, so so obviously we're talking about mobility. Of electrons. We're talking about, so metals, they seem to be very free, and in other materials it doesn't seem to be, it's not as good, basically. And this is actually why static electricity devices are not used in modern day electronics. So yeah. So the relative mobility of electrons is the relative mobility of electrons it's called electrical conductivity. Okay. So, and conductivity is determined by the type, often by the group they are in. which obviously makes sense because the amount of electrons in the outer shell. So it is determined by the type of atoms in the material, which is of course defined by a number of protons, which is what defines the elemental identity. Okay. Yeah. And also by the sort of Lewis, I could say Lewis structure. I think there's other structures as well, but I'm not going to go into that because that's chemistry. And also by how the atoms are linked together. Okay. So we mentioned the metals here, and then we did other materials here. And what I was basically doing with that is, so materials with high electron mobility so many free electrons, they're conductors. Gone a bit far there. So materials with, let's just get a bit down here. So materials with low electron mobility so few or no free electrons, these are known as insulators. Okay, so there we go. It's fairly self-explanatory. So we've got conductors and insulators. So let's do a list. So we're going to put conductors on the left here. And insulators on the right. And hopefully I'll be able to fit it in the screen space I got now. It's quite good getting rid of that ribbon. It does give me a decent amount of space. So let's just put some down. So we've got silver. That's a very, very good conductor, silver. Copper. Gold. Aluminium. That's a real test with yeah. And iron. Steel. Brass. Bronze. Mercury. Graphite. Carbon. Dirty water. And concrete. So there we go. So yeah, so keep in mind that it doesn't necessarily have to be a metal that we're dealing with. Something can conduct without being a metal. It just so happens that metals are the bulk of the conductors. And what about insulators? Well, as we said before, glass is an insulator. Rubber, oil, asphalt, another one in sort of construction and stuff. fiberglass, porcelain, ceramic, quartz, dry cotton, dry paper, dry wood, kind of the same thing obviously, plastic, air, diamond, and the last one is going to be pure water instead of dirty water. So yeah,